This is the Western Arctic Ocean. 8 million square miles of solid, impenetrable ice. One of the most inaccessible regions on Earth. The center of the polar ice pack is virtually unknown to science. No ships have ever sailed to the heart of this frozen frontier. Its waters remain uncharted. Even its biology is a mystery. On July 17, 1994, the United States and Canada sent a team of scientists north on 2 icebreakers to take on one of the most powerful forces in nature: ice. And at the heart of that powerful force, the North Pole. The ships are sailing up the west coast of North America, and after a brief stop at Nome, Alaska, they'll continue north through Bering Strait. Their ultimate goal, science. Their field of operations, the top of the world. The U.S. Coast Guard's Polar Sea and the Canadian Coast Guard's Louis S. Saint Laurent are on a joint scientific mission to assess the impact of global warming and pollution on the Arctic. A challenge so immense that no one country, and certainly no one ship, could tackle it alone. I'm Wayne Grady, and I've been invited on this trip to make a record of the expedition. Right now, the ship seems almost empty. Just me, the filmmaker Stefan, and the Coast Guard crew members.
Signature?
But that'll change at Nome when we pick up our passengers, 70 of them, the top ocean scientists from across the continent. They'll spend the next 2 months conducting the most intense scientific investigation of the Western Arctic Ocean ever undertaken. What they find will help determine North America's environmental policies for decades to come.
Coast Guard Hilo 359, Coast Guard Hilo 359, Coast Guard to the Polar Sea, Channel 6 BHF.
As the scientists arrive on board, the wide range of their expertise becomes evident. The Arctic is going to get a thorough top-to-bottom examination. Chris Measures is an ocean chemist. He's here to gauge how much life the Arctic Ocean can support and how that life may be threatened by chemical changes in the water.
We're getting to the point where we actually have the technology to manipulate the planet on global scales, but the point is we also will suffer the consequences of global catastrophes if we do it without knowing the consequences.
Kathy Ellis will measure the radioactivity that works its way into the Arctic from nuclear waste and bomb tests.
The Arctic Ocean is a recipient of a lot of the contamination in the southern areas.
The Canadian science leader on this expedition is Eddie Carmack. To Eddie, the threat of global warming is real. The Earth's climate is changing, and the changes can be seen most clearly in the high Arctic.
The Arctic will warm first and fastest, and therefore if you're looking for confirmation of global warming and you want to see a sign that it has started and an indication of how fast it's going to occur, this is the place to go and set up your experiment.
Eddie and the 2 other science leaders have been working for 5 years to get this expedition underway. Until today, penetrating deep into the Arctic Ocean has been a dream. Now, at long last, it's about to become a reality.
If I could get your attention for a moment, for the next couple of months we're going to be working together and sleeping together and so on. And I don't mean that the way it sounds. What I'd like to do is we could all introduce ourselves together. Go ahead.
I'm Knut Agard. I'm from the University of Washington in Seattle, and I'm the science coordinator for the 2 ships.
Malcolm Ramsey, University of Saskatchewan, working on polar bears.
I'm Jim Swift, interested in physical oceanography, and I'm working with the CTD Rosette water sampling program.
Rico, Dick Hain.
Steve Oliver, Baker.
Gordon Studley, radio officer. We'll try our best to get all your communications through.
Sean Farley, working with the polar bears.
Al Jarvis,
Jack, canteen, also manager of the ship's bar. Thank you.
The last thing I would like to say is that when we're working in the ice, I don't enjoy a lot of people on the bridge. However, we will try to accommodate you.
Everyone is very eager to get into the Arctic, to get into the ice. From the captain and crew to the scientists, I think everyone agrees that this is when the trip really begins. You can see why it's called the Pacific Ocean. It's very calm. This is like the South Seas. We even have an albatross following the ship that's been following us for the last 3 days. They say it's really good luck if you can get the albatross to land on the ship. So far this one hasn't landed, but it's brought us luck anyway.
We're on course on 258.
Although cooperation between scientists and the Coast Guard isn't new, this is the first joint Canada-U.S. venture into the high Arctic. Captain Lawson Brigham, on the American ship Polar Sea, is aware of the historical significance of our joint mission.
Here we are in 1994, and we have an expedition that is, in many respects, like the expeditions of the 18th and 17th centuries.
Aboard the Louis, Captain Phil Grandy focuses on the unique aspects of the voyage.
It's the first time ever the Canadian Coast Guard have ever had the opportunity to look this far north, and I'm very honored to be that one to even look that far north with a Canadian icebreaker. I hope that I can make it successful.
That long look north will take us out of these calm waters into the unexplored areas of the western Arctic Ocean, through ice conditions more severe than anything either ship has faced before. More than 80% of the polar ice pack sits between us and the North Pole, which is why previous expeditions into the high Arctic have taken the eastern route. As Steve Wheeler, ice pilot on the Polar Sea, explains, it's just plain easier that way.
If I were to plan a trip to the North Pole only to go to the North Pole, I would definitely start from the Laptev Sea, Kara Sea, Barents area. In other words, from the eastern Arctic. The western side, you've got just that much more ice you have to break to get up there.
The last captain to attempt the pole through these waters didn't know that. George Washington DeLong thought he'd find warm, open water all the way to the pole, perhaps even a new continent. He headed north from San Francisco in 1879 aboard a small wooden ship, the Jeannette. At about 70 degrees, not much farther north than we are now, the Jeannette was locked in the ice for 2 years before being crushed to splinters. Only 9 men survived. Before we set out, we weren't given much more of a chance of reaching the North Pole than DeLong had. But now that we can smell the cold air blowing off the ice, all bets are off.
You want to lay odds on getting to the pole?
Oh, I think we'll get to the pole.
To make it, we'll have to travel through more than 3,000 miles of unexplored ocean. For scientists like Lisa Clow, that provides an opportunity to ask some basic biological questions, like what's up here? What does it do? How does it live?
In some ways it's cutting edge because no one knows what has gone on before, but in other ways we're doing things that they've done for centuries.
There are also 2 Inuit on the expedition, Ulatita Iqaluit, a young Inuk hunter from Grise Fiord, and Akaksak Amagolik, a guide from Resolute. Akaksak has already been to the pole 4 times, by snowmobile, by foot twice, and once by air. They've been invited to share their knowledge of the North with the scientists. Malcolm Ramsey is especially counting on their help in his search for polar bears.
Without the information, the basic biological information that we're gathering, it would be impossible for any agency, any government, to set up suitable safeguards to ensure the continued survival of these unquestionably wonderful animals.
Animal life everywhere on the planet will be affected by global warming, but the effects will show up first in the Arctic.
If our policymakers and our planners want to know, is the globe really going to warm, they need to go where they can feel the pulse.
Every 1 degree temperature rise at the equator means a 4-degree rise at the North Pole. Such an increase would vastly reduce the extent of the polar ice cover. What effect would that have on the rest of the planet's climate?
That's what's really exciting about this particular trip. It's the variety of questions that are being asked and the interaction among disciplines that would have never taken place if we'd have stayed in our labs at home.
Remember what I said about how calm the ocean was? Well, that was yesterday. Today we got 40-knot winds, and that doesn't seem like very much, but it's enough to kick up 16-foot seas, and we're rocking quite a bit. What can I say? Things change.
Scientific expeditions to the Arctic have traditionally included artists and writers, and our voyage is no exception.
Starting with Chris Walker, I see you first, a painter. Now, if you've looked at Chris's work, you'll see a tension between nature and man. If you think of the objective of this cruise, it's to talk about the effect of global change on nature. So I think Chris's work fits in very well with our objective.
Actually, it's going to be great. I'm looking forward to this.
You nervous?
A little bit, just a little bit. But it's a kind of a positive nervous feeling, you know?
Sylt Rabbit is filling a number of roles. He's a doctor, photographer, primarily an artist. He's trying to pick up the color and the emotions of the people doing the work. Wayne Grady, you'll all get a chance to meet him. He's the official science writer for this expedition and the documentarian. Wayne distinguished himself by covering the Canada-China dinosaur project. The guy there, Stefan Pedalowski, will be filming everything as it happens.
Stefan's roving camera soon becomes a familiar eye at every ship function, including amateur talent night. It's hard to create a disco atmosphere in 24 hours of daylight. But with 150 crew members, there's always someone off duty willing to give it a try. As we pass the last island off the east coast of Siberia, we have our final sight of land for the next 2 months. The water in the Chukchi Sea is as smooth and calm as any sailor could wish. From here, we head due north until we're actually into the ice. Our projected route will take us over most of the underwater features in the Arctic Ocean, the Canada Basin, the Mendeleev Ridge, the Lomonosov Ridge, until we reach the most distant point on the globe, 90 degrees north, the North Pole. Then, we turn around and come back along a second path, ending up in Point Barrow, Alaska, sometime before the ocean refreezes in late September. Into the ice. This is our first 5 seconds into the Arctic ice. It's about 70 degrees north in the middle of the Chukchi Sea. So if you draw a line from the top of Alaska to the middle of the Chukchi Sea, that's where we are. We're in very, very small concentrations of first-year ice. It's not very thick. It's broken up and being blown this way. The ice face itself is probably a couple of hours north of here. So we're not really into the ice face. This is just sort of a hint of things to come. After being crushed, DeLong's ship drifted with the ice across the Arctic Ocean into the Greenland Sea. Finding pieces of the Jeanette in Greenland gave Norwegian explorer Fridtjof Nansen the idea that if he deliberately got his ship, the Fram, stuck in the ice at about the same place the Jeanette went down, then the drifting ice would carry him across the pole. It was a great idea, but it didn't work. The Fram and her crew drifted north for the next 3 years, but missed the pole by 350 miles. Nansen's example inspired a Canadian mariner, Joseph Elzéar Bernier, to plan a similar attempt.
Bernier was less of a scientist, but more of a seaman. He had a very long experience as a master navigator. He started when he was 12 or 13 years old.
He convinced the Canadian government to buy him a ship and to provision it. His plan was to sail up through Bering Strait in 1904 and set into the ice 300 miles east of where Nansen had placed the Fram. But at the last minute, the Department of Marine and Fisheries called it off.
Word reached Ottawa that there was a Yankee bootlegger peddling alcohol to native peoples in Hudson's Bay, and they thought that taking care of that problem would be more important than a far-fetched trip to the North Pole.
From what we know now about ice drift patterns, Bernier's plan might have worked. In fact, his projected route to the pole is almost exactly the same as the one we're following now. We enter the ice edge on July 28th at 72 degrees north latitude.
A ship like this uses a huge amount of fuel, and if you can save an hour or over a very long trip a day, it could mean quite a bit.
Fred Coates is the ice observer on the Louis.
My job on the ship is to provide as much ice information that will allow the captain to make serious decisions about which way to go. The ice has different color signatures. First-year ice has a very darkish appearance. It's the weaker of the ice. Second-year ice is slightly stronger, a little more fresh water in it. The other thing is the color of it, which is a gray-blue color. And then we go into the multi-year ice. Usually the multi-year ice stands up higher. It has a more rounded, knobby appearance to it. And the pools of water, or meltwater, have a very azure blue look to them.
And I came up with a basic study of some of the colors that the ice takes on when it's beneath the surface of the water. And it's funny, even the color of the water and the color of the ice started to change very slightly too, like from either blues to greens or from greens to blues, or somewhere in between that. A kind of strange type of cobalt blues and phthalocyanine blues and all kinds of strange formations to complement that as well.
For our purpose, it's the same thing. It's old ice, and we look out for it and try and avoid it.
Now that we're into the ice, Malcolm is hoping to see polar bears.
On this cruise, we have 2 ships. We have people specifically looking for bears. We have 4 helicopters fanning out, and we feel that if there's a bear in the area, almost certainly we'll find them.
If there's a bear in the area. There's no scientific evidence that bears are found this far from land, but that may be because no one has bothered to look.
It was assumed that as you got further away from the continental shelf, that the productivity of the oceans would drop dramatically. And without the productivity lower down in the food chain, there just wouldn't be enough seals to support a polar bear population.
Malcolm doesn't spot any bears on his helicopter flight, but he does find the remains of a ring seal that has recently been killed and partially eaten by a polar bear. So there are bears out here. The question now is whether they live on the sea ice full time or travel here from the nearest land, which now is more than 300 miles to the south.
The tone here has to be just perfect. If the tone isn't on this particular side, then it will kill it.
In his makeshift studio below decks, Syl Drabbitt begins his first portrait of the trip. Art Grants, chief scientist aboard the Polar Sea.
I guess. My role has been mainly to be sure that we all get on here, have adequate workspace, essentially be a coordinator of the different groups.
Now I'm going to start moving the eye.
Art's field is marine geology, what lies under the Arctic Ocean. At our first science station, Art and his geology team take a sample of ocean bottom sediment that has accumulated over millions of years. One of the geology team's tools is the piston core, a long tube weighted at the top that's dropped like a spike into the soft mud on the ocean floor.
One of the things that got me into this research was, how do you explain the ridge systems of the Arctic Basin? How do they get out there? What's their story? And the answer to what happened lies in the fact that we dropped a series of piston cores which picked up bedrock beneath the thick section of muds. And so our hypothesis is that some of this bedrock and a couple of spectacular cores match quite closely similar rocks in the Canadian Arctic Islands.
Let's go! Get up quick, man!
Millions of years ago, North America and Siberia were part of a single landmass. Art suspects that the Canada Basin was formed by the fan-like spreading of the two continents. Identical rock samples from here and the Siberian Sea would support that theory.
So from this, we can get the age of opening of the Canada Basin. Beginning about 132 million years ago, there was a prehistory of failed drifting that started possibly as early as 170 million years ago.
As we cross the Arctic Circle, that imaginary line that divides north and south, we say goodbye to all our preconceptions about the Arctic. The hazing is reserved for those crossing the circle for the first time.
Now we're together on a ship and we are all struggling with a common question, and people to get together at dinner or in the lounge for a drink after the day's work, they have a chance to say, well, I noticed this about the bears, and the contaminant specialist will have his input into it. We sailed with a science plan, and it laid out what we hope to accomplish, but now you're starting to see the science plan grow as sort of novel and unpredictable ties are starting to form. Science is sort of like that. If you can plan the outcome, you're not really delving too deep into the subject.
We're going to see a whole bunch of these as we come down here, probably down to 23.
Knut Agard, who's the expedition leader, I guess could be considered the godfather of the Arctic. He might not like that expression. Knut has made some incredibly major contributions to the understanding of the circulation of the Arctic. He and Eddie Carmack and Jim Swift, both of those two were his students, have done some really impressive work in this area.
Jim Swift heads the oceanographic team that is sampling seawater from the surface right down to the ocean floor.
It's not gone out of fashion to measure the oceans well. In fact, we're finding out we have to measure the whole world ocean really, really well to try to understand how it works.
The water samples are collected by a device called a rosette, 36 plastic sample bottles arranged in a double ring around a metal frame. The rosette is lowered over the side by the ship's winch to within 10 meters of the ocean bottom. A sensor on the frame signals that it's in position, and the deck crew closes the first of the sample bottles electronically. Then they raise the rosette to the 35 other levels that have been chosen for sampling on the way up. The water is carefully extracted from each of the bottles and tested in the ship's labs for a wide range of contaminants. Natural elements such as oxygen and carbon dioxide are also measured.
You can do oxygen on number 1 if you want to. Terrific.
Yeah, we're just breaking through some dirty ice here. That I thought it had stopped, but we broke some flows and some large flows, and it's pretty thick, A lot of sediment. Yep. Yeah. Okay.
Bye. Okay, we'll go up to the LOFCON. Can you do this around, bud?
The LOFCON?
Yeah. Nobody queasy on heights or anything?
Not me. Lieutenant Junior Grade Karen Arnold takes us on a tour of the Polar Sea's LOFCON, a modern version of what used to be called the Crow's Nest. A PhD in anthropology from Cambridge University, Karen signed on with the Coast Guard to see the world, or at least as much of it as she can see from up here in the LOFCON.
when you're in the ice, you need to be able to see astern as well as ahead, because you're basically backing your propellers and your rudder into the ice. So you want to know what you're hitting, and you want to know how hard you're hitting it. And if at all possible, you want to back yourself into ice that's already been chewed up. So this kind of gives you the all-around viz. And this is how you steer the ship. That's it. That powers 13,000 tons of ship. Wow. As they told me when I first got on here, whatever we hit will break. If it's another ship, if it's a pier, if it's ice, if we hit it, we'll break it. This ship vibrates and is pretty loud down below decks. It sounds like metal on metal when you're down below the water line.
The first decent ice I got into, which was on this ship, I spent 14 hours in a LOFCON before I realized I had been up there that long, because I was just absolutely fascinated by this stuff. When you're sailing the other types of vessels, the rule is not to hit anything. The idea with an icebreaker is that, yes, you do hit it. You hit it as hard as you can.
Not all the ice we meet can be broken by head-on smashing. Most of it can be dealt with in a way that's easier on the ships. Mark Cusack, chief engineer aboard the Louis, recommends a gentler approach.
With this particular bow, it rides up quite a bit more and has a different shape. It brings more of the weight of the ship to bear on the ice. I've seen a number of times, just where I thought the ship was going to stop, the ice will break, and when it breaks, it allows the propellers to get a little bit more momentum and sort of push it up on the next piece and break down again.
Depending if you can get cracks working through it will depend on where your power strike is going to be. But you break the ridge down a little bit and then you just nail it.
It wouldn't matter how much horsepower you have if conditions aren't favorable. It's one thing about going to sea. It kind of keeps you a little bit humble, keeps you just where you fit in the overall scheme of things.
And this is the track for the ship. We'll be coming to this point and then going up here, over to here, and then up to the North Pole here.
Where are we now?
And we are at this position here, number 15.
Even this early in the voyage, heavy ice makes it difficult to predict when we'll get to the next science station. But with 24 hours of daylight, it doesn't really matter. Even at 2 o'clock in the morning, the scientists are ready to swing into action. Just being able to get out onto the ice is exhilarating. It's as though we've arrived on some unexplored planet. We're just glad to be busy, to be finally doing the work we've been planning and waiting for 5 years.
It's completely fresh.
Tony Gao studies the differences between sea ice and glacier ice. Glaciers can be thousands of years old and several miles thick. Not so for sea ice.
The average life of a piece of ice probably in the Arctic Basin is 7 or 8 years. And the average thickness is probably somewhere between 2.5 and 3 meters.
Ron Perkin wants to know how the ocean's physical properties change at different levels. The instrument he uses is called a CTD, for conductivity, temperature, and depth.
1,500 meters of wire, and usually we get down to about 1,450 meters because of the bend on the line.
It records changes in the ocean's salt content and temperature as it drops down through the water column.
And we just let it run out while the instrument's warming up, and then when we haul it up slowly so we get lots of data.
To build a better icebreaker, you need to know a lot about ice. That's where Mary Williams comes in.
So we get this analyzed, we'll know exactly what this ice is. That's great.
Knowing how sea ice forms, how it grows, helps determine the best way to break it.
1.5 meters. Yes, right. We finally found the combination of teeth and dogs on the bottom of the barrel that allows us to pull the whole core out. Before we were losing part of the core down in the hole.
Terry Tucker is studying the pools of summer meltwater that form on top of the solid flows.
We know there are melt ponds here. We don't know what the concentration of melt ponds are, and we don't know the characteristics of individual melt ponds. If we can better characterize the surface of the ice, we will be able to make better predictions for the response of the ice cover, say the CO2 doubles and the atmosphere warms.
300 nautical miles north of Alaska, we're finally off the continental shelf and breaking into the permanent polar ice cap. Despite the heavy ice, Malcolm still hasn't seen any bears.
If any polar bears are spotted, we'd like to know. The arrangement is we're going to try to capture them, and of course, and bring them back here, right? And we're going to use it. Well, you in front, you can run.
Guys, would you try to be nice to Malcolm for the rest of the trip?
The first polar bear sighting sends pilot Steve Hempel and Malcolm out in a helicopter to try to capture them. Unsuccessfully, as it turns out.
One female we got on this trip, she had a single cub, and the cub decided to go just the completely opposite direction. So we thought we'd be able to dart the mother and then go back and get the young one, but after looking at it and seeing the separation increasing so quickly, we decided to bring the group back together.
The work that we do is obviously disruptive in the lives of the bears. I mean, we're stressing the animals by chasing them with helicopters, by shooting them with darts. I'm quite aware of that disturbance. My justification for it is that polar bears are being gravely impacted by humans through other activities, and that it's only through an understanding of the population dynamics and the basic biology of these animals that we can set up appropriate safeguards to ensure the continued survival of the populations.
Biologists working with endangered species are used to being criticized for disturbing the animals they're trying to save. Even Ulatita, who lives in the Arctic, questions Malcolm's methods.
So in a way it does bother me, because I don't like to see my bears up here being collared and darted. I mean, we eat those. This is the bears we eat.
Bears, along with humans, are at the top of the Arctic food web and are an important link in the long chain of contamination that begins with plankton and ends up in people.
When organochlorine pesticides began showing up in not only in the top of the food chain, but also in the mother's milk of Inuit peoples, we began to worry not only about local spills and dumps, but also how were pesticides getting into this pristine environment where people didn't use pesticides.
There are communities of Native people living in northern Canada for which Health and Welfare Canada has suggested that the women in those communities do not breastfeed their infants because the organochlorine levels are so high in their tissues and in the mother's milk that it exceeds the levels at which Health and Welfare Canada feels is safe for ingestion. The bears are at comparable levels or even higher, but of course we can't go to the bears and say, please don't breastfeed your offspring.
People say there's something in the food chain that you guys are eating. I mean, that won't automatically stop me from eating my country food. I mean, you have to produce the evidence before I stop eating my country food. Something within an eyesight.
It's an Arctic cod. One of the guys on the Louis Saint Laurent came up with the idea of collecting these to test for contaminants in the water, so PCBs and things. So I'm collecting them for Robbie. Robbie McDonald has spent the past few days peering over the rail, waiting for the Louis' bow to churn tiny Arctic cod up onto the ice. Fish, he says, are beautiful integrators of contaminants. When he spots one, he signals Captain Grandy on the bridge to stop the ship and then clambers over the side to collect his trophy.
It's the step between the zooplankton and seals. And so it's an important little gatherer in the system. The other thing, too, is that we don't know really how the organochlorines distribute themselves, but it may be that most of the action happens in the top 10 meters, say, and that really what goes on in terms of putting the organochlorines into polar bears is mediated by the activity that goes on in ice and around ice. It's ice algae, it's zooplankton associated with ice, and these little cod and the seals, they all live with the surface, and surfaces are an important area.
At these latitudes, adult Arctic cod are about the size of smelts. So far, Robbie has 8.
Well, these guys will be measured, sexed, aged, and they'll take samples out of them for organochlorine contaminants, and we should get a sample also for carbon isotopes. We just need a 20,000-ton ship to do it.
The more Ulatita learns about problems in his environment, the more concerned he becomes.
Most of my food comes from the ocean. What they show me, I don't really want to hear.
The problem with contaminants in the high Arctic is compounded by the fact that they show up in ever higher concentrations as they move up the food chain. The process is called biomagnification.
Things eat other things. And as you go up each level, that particular component can magnify further and further. For example, if I measured HCH in the water, and then I measured it in fish that were inhabiting that water, I might find that they would be 500,000 times higher in concentration of HCH than the water column they're living in.
The danger of biomagnification is substantially greater up here. A toxic substance that has a residency time of only a few hours in the warm waters of the south may hang around 60 years in the Arctic. It's a chemical conspiracy that turns the Arctic into a toxic sink for pollutants produced thousands of miles away. This explains how an Inuit mother's breast milk can contain traces of a chemical insecticide like toxaphene sprayed 30 years ago on a cotton field in Alabama. As we work our way deeper into the ice, our progress becomes more of a struggle. This is the endless Arctic, and we can't help being affected by the solitude. We each find our own ways of breaking the routine.
And that's mistake number 1.
Those who have been on long voyages before know that this sense of isolation will pass, and a deeper feeling of community will develop.
B15. Bingo. I was a bad boy. They made me peel potatoes.
That's it. We're finished. We're getting worse.
There's still the relief of a quick phone call home. I've discovered the secret to ward off seasickness is to eat a lot. This is satellite. This is on the Inmarsat. Don't tell Arnie how much it costs. $30 a minute. Oops. That's a deal. Hasta la vista.
Really looks jumbled, doesn't it?
Yeah, there's a lot of dynamics here in this area. If it gets to that pool over there, we'll be doing all right.
Art Grants wants to take a reading of the ocean bottom at the next science station using sensitive seismic equipment. Towing seismic streamers requires tricky coordination, with both ships working in tandem through the ice for up to 100 miles. At one end of the tow line is a triangular array of transmitters firing a sequence of sound waves down to the ocean floor. By measuring the time it takes for echoes to return to the hydrophones attached to the streamers, Art and his team can get a rough picture of the history of the Arctic seabed going back millions of years. Such a plan requires fairly navigable ice, and right now, it looks as though the Arctic isn't going to comply.
Yeah, I see what you're talking about. I'm a little concerned about getting up around the corner here to the right. I do see a lot of pressure up there, but I don't see any water through it. But we're going to have to stick the nose up there and take a look.
We've had hardly any time on this trip when we have not been striking some chunk of ice, if not continuously, then at least every few minutes. It just has not been an easy portion.
Tell the Louis to hold off right about at this position. We'll take a run up the end of this Polinia and see if we got an outlet to the north, because I see good water up there northeast. Otherwise, we may have to come back to this one and beat her up there to the northwest.
We've actually been gradually forced somewhat west of our original track.
The captains and science leaders have a difficult decision to make. They can send two ships 20 miles out of the way under unpredictable conditions, or they can put Art's seismic program on ice.
We wanted to do a seismic line from the northern Canada Basin onto Mendeleev Ridge.
Well, it's a difficult thing to be towing in ice-covered waters.
But ice conditions made it seem inadvisable to the project leader, Knut Agard, to go up there.
The places where it was desired to make those measurements have so far not really been accessible.
And so I canceled it. And hopefully we'll get credit for that time saved later on in the expedition.
Heavy ice is bad news for Art and the other geologists, but not for Malcolm and his colleague Sean Fairley. Heavy ice means polar bears. Malcolm succeeds in darting 3 bears, a female and her 2 cubs, the first evidence anyone has had that polar bears give birth this far from land. Each bear receives a dose of tranquilizer adjusted to its weight, so the mother and cubs will wake up at the same time.
We take tissue samples, we take a blood sample, we also take a fat biopsy from the skin area over the rump, and we use that to look at contaminant levels, particularly organochlorines that are stored in the fats.
102.8 for the female.
Before I came on the trip, virtually every polar bear biologist on the face of the planet suggested that it really wouldn't be much use to come up here. There were no bears. I would spend a lot of time and accomplish very little. And in fact, I feel we were very successful in our work.
Oh, these G's that are rich.
Yeah.
Just like cream.
Yeah, it's one of the richest milks there is. It's like whale's milk.
How many vials do you want?
I just need 1 vial of that.
Okay.
Thank you.
We're now 1,000 miles from the nearest land, and it's beginning to look as though there's a whole polar bear population living permanently on the Arctic ice. This would add significantly to the current estimate of the world's total polar bear population of around 30,000 bears. What would happen to these ice-dependent animals if global warming shrank or completely melted the polar ice cap?
Okay, we're off, and we got, it's going haywire, Malcolm. Steady, 479.
479. You got this, Steve?
479.
7893.
Right here.
It's turned on?
Yep, I got a signal out of it the other day, so.
Malcolm fits only the female with a radio collar. Collars would choke the cubs as they grow up, and the necks of males are thicker than their heads, so the collars would slide off. Radio signals from the female's collar will be picked up by satellite.
these are the sort of data that we would get. These are some data we've collected in Baffin Bay, Davis Strait. Those are the movements of a single bear over the course of the year. The different colors are just different seasons. And there's an overlay of some 10 or 15 bears over the course of a year.
On August 14th, after breaking nearly 1,200 miles of ice, we approach 85 degrees north. Until now, the only North American ships to make it this far have been submarines. The first was the USS Nautilus in 1958, which made it all the way to the pole.
We don't care about subs. We're talking about surface ships. Okay, we don't care about subs. Those are the old days. They cheated, that's right. They didn't have ice to break through.
The feeling is that taking a submarine under the ice to the North Pole is like taking an elevator to the top of Mount Everest. It doesn't count.
Oh, Mr. Wheeler's history?
Congratulations, Nancy. You just piloted the ship past the northernmost point ever achieved by a U.S. surface vessel.
Yeah, congratulations, Mr. Carroll. Long way from the academy, isn't it?
It's nice to be able to go down in the record books even for a little while. And if we make 90 north, nobody can beat that. Can't go any further north, so.
Reaching 85 north isn't all good news. Most satellite communication systems were not intended for use at the top of the world. Their signals travel in arrow straight lines, and the Earth is curved. North of 85 degrees, the signals from most satellites pass way over our heads. It's really touch and go. Within a few minutes or a few hours, we won't be able to get any more Inmarsat phone calls. So today is probably the last day for any kind of phone voice communication with the South. Bob Rittner has been collecting information about ice conditions from the satellite computer system known as TerraScan. At 85 degrees, TerraScan starts to fade as well.
The DMSP, which is a very narrow bandwidth, we're not getting it all now. And I think it may be the fact that it's very narrow and we're getting some kind of angle error in here. And we're thinking gyro, we're thinking software. This has never been done before.
Steve May, in the Geology Dry Lab, has also had a computer crash.
When we went north of 84, it's just like when you make a map of the world and you try and unfold the spherical world and things like Antarctica spread across an entire map. And when we did that at 84, that's where the math function breaks down, went to infinity, and craps out.
The satellite is in and out here, Norm, over.
The Global Positioning Satellite, or GPS, may work this far north, or it may not.
As we get further north, the satellite's coverage isn't as good. It's likely that the GPS units themselves will go out, and we actually have had one crash of the GPS already. There are those who are not sure how far north we will have GPS and how we're going to define when we're right at the North Pole, because our GPS units likely aren't going to tell us that.
For the moment, we're less concerned about the GPS working at the pole than we are about getting to the pole at all. The last ice maps we had showed thick multi-year ice between us and the top of the world. With the ice constantly drifting, who knows where the worst of it will be a week from now. All Fred can give us are short-term ice forecasts from his helicopter reconnaissance flights.
432.
The thought of taking on the polar ice cap without satellite backup is nerve-wracking.
We try to jump up into this stuff, we're going to be wasting our time. Slammer hard astern, you wanted to take a left back about a half a ship length. You got no future this way. Back her straight across the Blenny and take that left branch out. I'll call the Louie and hold them where they're at.
We're 28 days and 1,200 miles into the Arctic Ocean. So far, the science has gone extraordinarily well. Art Grant's geology team has suffered setbacks, but the other 49 programs are accomplishing exactly what they came here to do: investigate the least known ocean in the world. But there's still a lot to explore. The question now is, will the ice let us get to it?
That kept me
That's it. We're finished.